So now what I'm going to talk about is pressure. Okay. And the relationship between pressure and the depth of water. Now, pressure is equal to density of either the liquid or the water times by gravity times by the depth. So as I can see, as I'm going down more, as I increase my depth, I increase my pressure, which kind of makes sense because I've got basically more force above me. And we know that pressure is force divided by area, all right? So if I go down deeper, I've got more force. More force means more pressure. So this is the actual relationship between pressure, density, gravity, and depth. I just got to multiply the three of them to get my pressure. And this works with liquid as well as gases. So if I'm, for example, on Earth, right, and I have more atmosphere above me, my atmospheric pressure increases. As I go higher up in the mountains, my atmospheric pressure decreases. There's less gas molecules above me. Now, this image right over here, I actually did an exam question just the other day about it. They actually used this image, right? And they said to me, they said in the question, why does this shoot out more than up here? So I'm going to label this A, B, and C. Now, I know at point C, the last point over there, I have the greatest depth. Now, because I've got the greatest depth, okay, we know pressure is density times by gravity times by depth. So at the bottom, I have the same density, same gravity throughout. A, B, and C, they all have the same, okay? A, B, and C all have the same density and gravity, but the depth changes. At C, I have the greatest depth. Because I have the greatest depth, I've got the greatest pressure. And because there's a greater pressure, this could shoot out further than A, for example. A has a bit of pressure, but hasn't got as much pressure as B or C. So the water doesn't shoot out as far because the pressure of the water is going to be lower.